This is CCS America's series Let's Talk Lighting, where we discuss machine vision, lighting techniques, and technologies so you can solve lighting challenges more efficiently in-house. I'm Emily Ting, marketing specialist at CCS America and co-host of this series together with Lindsey Sullivan, our technical marketing manager, who is here to share all her knowledge and expertise from her time as an applications engineer. Lindsey, how are you today?
Good. Yeah, Minnesota weather starting to get warm, so I feel like the depression is actually seasonal, which is always good news, you know. But yeah, it's getting good. It's nice to finally be able to go
Yeah.
outside and not just be cold.
Yeah, honestly, that's still the feeling over on the East Coast, but at least it's just sunny and cold today instead of, cloudy and cold or like it was on Tuesday for like a couple of hours actually snowing, which was so depressing. I'm so ready for it to be over.
Having it be cold on Easter is just like more sad. Like if it wasn't Easter, I wouldn't have cared so much that it was cold, but because it was Easter, it was just like it's not supposed to be like this.
We're supposed to be welcoming the spring in. Hopefully, we're finally on our way after, having like 8 winters so far this year.
Yeah.
But in any case, it's time to talk some lighting. And today we're kind of doing part two of a topic that we covered a few months ago, which is lighting terms. Um, that you will often hear when you join the machine vision world. And it can definitely be confusing when you don't really know what these terms mean. And especially for the topic of today, we're talking about the terms that tend to get used interchangeably and, you think describe the same thing. And in some cases, it's basically the same, but in other cases, there is a meaningful difference, especially when you're talking about the physics or the technology behind it. As the CCS ghostwriter, there were times when I was writing things or translating things. I was like, oh, I can just, use these, flip them, no problem, because writing practice says don't use the same word over and over because it gets annoying, which it does. But then in some cases, I learned, nope, you shouldn't do that. So that's what we're going to talk about today. We've got a couple of, groups of terms, and Lindsey is going to, with all her expertise, shed light on our
Got him.
lighting nerd puns. Sorry to the audience. Shed a light on the actual meaningful differences between them, or if they're the same and it's totally okay to use them interchangeably, then, use those words with a guilt-free conscience going forward after watching this episode. um, so the
Big
first
guilty,
set of
like
terms
was it specular reflection? Oh my God.
yeah, and you already mentioned one of the first in a group of terms we're going to discuss today, and that is, the difference between specular and scattered and diffuse. As they're like loosely used, and I guess first start off by, are they actually the same or are they describing different light behaviors?
Yeah, they are different actually. They're pretty different. And it's interesting because there's so many different ways to talk about like how light reflects off a sample and like what it's doing. So hopefully this makes it a little more clear. When somebody says specular reflection, they're talking about the light that all comes down. This is why we have to do video because I always use my hands. The light that comes down and is like directly reflected off the sample where the angle matches. That's the specular reflection. And so like that would be the light that we're capturing when we get bright field images. So it's one of those things where you want to know, specular reflections, that direct light coming down typically produces a bright field image. If you're capturing all that light, if you're not capturing it, that's when you get the dark field image. So when we say scattered, that is how the light is reflecting off the sample in every direction. And that the difference between specular and scattered is what your sample is. So if your sample is like a mirror, you'll have all of that be specular reflection. But if your sample is like a piece of paper, then it's all going to be scattered. And if your sample is like something shiny, you'll get a little bit of both. So that's kind of the difference between those two. And if it's scattered, it shines, it reflects off in all directions. And the scattered light is what you capture when those dark field images are. So, like a dark field image would be the specular reflection, or the light shines down, specular reflection shines away from the camera, and the camera's capturing the scattered light that happens from your, etched code on the sample, something like that. Now, diffuse can kind of be used as a little bit of both. It's kind of like a little bit even more broad than the other two. Diffuse is like what type of light you have. Do you have a direct light or do you have a diffuse light, a low angle light, something like that? So it's more when everything's coming out in wide angles and providing a really flat, uniform image. It can also kind of be, you can also kind of describe your sample that way. If my sample is like a diffuse sample, it can just diffuse it. And you can use diffusers to make a light diffuse. So diffuse is less of how something is reflecting off your sample like the other two, and describes more of how the light is shining down.
So diffuse describes the light source, not the object's reflection. If anything, scattered light is similar to diffuse, but it's like the object's reflection. Whereas you wouldn't say, a scattered light source or a light source is emitting scattered light.
Correct. Yeah, exactly. You wouldn't say it's emitting scattered light. And you can use diffuse light on, shiny or matte surfaces, stuff like that. So it doesn't necessarily have to, diffuse light doesn't only produce scattered reflection, it can produce a specular reflection as well.
Yeah, so I don't know if this is a philosophical question or just hard science, but you can't say, or it wouldn't be accurate to say that scattered light is specular reflection happening in multiple directions, or is that
No, that
accurate to
wouldn't be
say?
accurate. Physics
No.
would say no.
Okay.
Yeah.
Physics says no. So cruel, cold, hard
Yeah.
science
Can't
says that's
really,
incorrect.
can't argue with physics facts. They don't care about your feelings.
No.
This is why I majored in math in college, because it was very yes or no. Like you got it right or you didn't, and there was no in between. And I liked that.
It is simpler that way, that's for
Yeah.
sure.
Yeah.
So, with that said, we'll cover the next set of terms. Again, talking about diffuse light, um, you know, what can often be used in a similar way as dome lighting, dome lights, and cloudy day illumination, cloudy day lighting. So, uh, do you want to give the basics behind all of that to start with?
Yeah. So a cloudy daylight is essentially a dome light. It's just another thing that people call it. The reason why they call it that is because it's essentially what a dome light is trying to create in machine vision is what a cloudy day creates outside, where you have all light just kind of coming from one direction without like a direct sunlight, something like that. And that's why the best, if you're going to take your family photos or whatever, the best day to do it is like a bright, cloudy day. You'll have incredible photos. It's the sunny days that make it challenging, and that's when they hold up those big reflectors on sunny days because they're trying to even out the light that shines on everyone's face. So you don't get what I have going on of like this half is bright and that half is dark because of my beautiful sunny window right here. So it's essentially, what cloudy day does outside is what dome does to machine vision lights. And that's why people use them interchangeably because, or like they'll say that term because it kind of gets the point across. And then a dome light, if you guys, are new to machine vision, that's where you have a big shell and then the LEDs shine up and then the shell is a bunch of a reflective material that reflects the LEDs down in a very uniform way. And then there's a camera hole right in the center of the dome that the camera looks through for a really even and uniform image. In order to make it uniform on your whole sample, usually the field of view has to be about twice the size of or the dome light has to be about twice the size of your field of view, give or take a few things, but they can get real big real fast if I've got a big field of view. Like we have this 400 millimeter dome light that's like yay big, but it comes in handy to
Yeah.
have. Yeah.
When someone says use diffuse light, does that automatically mean like use a dome light, or are there other ways to create the same effect?
Mm. This, if it was like a Venn diagram, it would be like diffuse lighting, and then a small circle inside would be dome lighting. So, like a dome light is a diffuse light, but there are other lights that are diffuse, so you can make diffuse. Talked about earlier, you can add diffusers. So, if you're using a bar light and you're getting hot spots and you're struggling to get an even uniform image, you can put on, more and more of a diffuser to even out those hot spots and get a uniform image. So, almost any light, if you add a diffuser to it, becomes a diffuse light, or other lights like flat dome lights are typically diffuse lights. Um, the HPR2, that's got a diffuser built into it. The multi-angle ring lights, those are considered diffuse lights. So yeah, no. Short answer, no. It does not mean you're using a dome light if you say you're using a diffuse light. But if you say you're using, sorry, it does. If you say you're using a diffuse light, it does not mean you're using a dome light. But if you say you're using a dome light, it does mean you're using a diffuse light. Yeah.
And so, using whatever type of diffuse light and how that light is getting diffused, is that the same physics phenomenon that's happening during a cloudy day, and that's why they're called like cloudy day illumination? Are those the same things, or is it just like an oversimplification so that it's easier for people to understand it?
Like a little bit of both, Yeah, I would say the clouds are maybe acting more as a diffuser than they are as dome light in terms of like how the physics is working, but the results are more in line with a dome light than they would be with a ring light and a diffuser. So, um, I wouldn't say it's the perfect analogy, but for the results, it's good enough. Gets the point across.
Yeah, so it describes outcome more than process.
Yes, that's a really one. This is why you're the ghostwriter, because I say things that don't make sense, and Emily comes in and it's like, or we can perfectly phrase it like this. Okay.
If anything, it's just me dumbing it down to my level. That's what's happening here.
Maybe
All
both,
right,
but mostly.
perfect. Yeah. Yeah, so all right. Then we've covered all the direct diffuse stuff. Next set of terms that we wanted to talk about today was telecentric versus collimated. Um, I think sometimes you hear it and relate it to like lighting and sometimes with lensing. So if you want to start by breaking down that difference, uh, go for it after you drink your water.
Yeah. So they are different, but they are used in the same system a lot of times. So collimated is talking about the light rays that are pretty much parallel. So they're coming up pretty much as straight as they can be. But telecentric is the optical design. Usually there's a lens or some type of illumination system involved to make sure that the camera is receiving, what the camera is looking down, it's looking down straight on and not from like an angle. So you have a telecentric lens means like you're looking completely straight down. There's going to be no distortion or anything like that. And if you're looking at like the top of, pens holding up, it's going to look the same in the center as it does at the edges with the telecentric setup. Versus a typical setup, it would be looking at the top in the center and looking kind of more down the pen as you get to the edges. So, in short, collimated they're both parallel. They both deal with parallelism. Collimation is the light and how the light rays are. Telecentric is the hardware in a lot of ways and how you're using hardware to get that optics to be parallel. Does that
So
make
it's like the
sense?
tool that is making things parallel, and collimated is the light itself being parallel.
Yeah, it's just more telecentric is like the lens or the imaging setup to receive it parallel. So yeah, maybe not making it parallel, but receiving it parallel.
Oh, that's true, because it's lenses. So that's when it's going back up into the camera. Okay. Um, can you have a collimated light source without a telecentric system and vice versa?
Yes and no. Yes, you can, because coaxial lights are typically considered to be
I
more
thought you said there
collimated
was only
lights.
yes or no, Lindsay.
Well, it's like, you know how like a square is a rectangle. A rectangle is a square, but a square is not a rectangle. It's just like that. It's like damage math all day today. Yeah, so if you have a not telecentric system, you can use collimated lights. And because your not telecentric system can receive lights from all angles, you'll still capture all of that, parallel light coming down. There's nothing to interfere with it. But on the opposite side, if you have a telecentric system and you use a not collimated light, you're only going to capture the few rays of this diffuse light that happen to be going straight up. So you're going to be wasting 80 to 90% of the light that's going off at angles. Your telecentric system won't capture that. So you'll have a really dim, probably pretty poor image versus if you have the telecentric system with that collimated super parallel light that's going to be able to capture all of that parallel light from the parallel telecentric system. So you'll have a much better image. So, yes, you can, but also no, you can't in your two-part question.
Are there situations where you've heard those two used interchangeably and, that was a bad assumption and I don't know, caused problems in an application? Or I guess more broadly in general, are there situations where mixing them up causes confusion or like, you know, design troubles that could have been avoided if everybody knew the correct definitions of both of those?
Yeah, I would say it since they both mean parallelism, it's not gonna derail a whole system if you said I have a collimated lens instead of a telecentric lens, because people will get the gist. You might have someone being like, "What? You have what now?" And same if someone said I have a telecentric light, they'd be like, "No, you don't." Um, so it's one of those things
It kind of
where,
reminds me of when we were, what was it, designing our like trade show booth furniture a couple years ago, and they were calling extruded aluminum speed rail, and neither of us had heard it called that.
yeah,
So there was like, I don't know, a good half an hour of the conversation that was probably more confusing to us than it needed to be if we had just known that speed rail meant extruded aluminum, or questions we wouldn't have asked. We wouldn't have needed to ask because we knew what extruded aluminum is and looks like and does.
yeah, that
So
that's a
just
perfect analogy. I do remember
yeah.
that.
It usually won't ruin things, but it just helps avoid a lot of confusion.
Yeah.
So a kind of machine vision adjacent example story to illustrate the importance of this
Yeah.
episode.
Yeah.
Um, all right. Next set of terms, which we've already brought one of them up, which is coaxial versus on axis. Those are, I think, usually used interchangeably to talk about the same form factor of light. We use coaxial. I don't know who uses on axis.
Yeah. I vividly remember because I worked at Keyence before this, and so I knew, machine vision and lighting and what a coaxial light was. And then I started at CCS and somebody called and they were like, I have a question about like an on-axis light. And they were going on and on about an on-axis light. And I was like internally panicking because I was like, I've never heard of this. Like, I can't look stupid and be like, what's an on-axis light? I'm supposed to know. And then like finally they pulled up a picture and I was like, I was panicking over a coaxial. And I was like, yeah, so that's when I learned at the time, learned it live, sink or swim, that they're the same thing.
Yeah, exactly. So are coaxial and on-axis truly interchangeable, or is one more precise or more correct than the other?
I would say like coaxial is probably the more correct, less confusion, obviously, per my story. You'll have less confusion if you say coaxial versus if you say on axis. Because other lights can be placed on axis with the camera. It just means it's in line with the camera. So like, a ring light could technically be considered like on axis with the camera. So I would say when in doubt, go with coaxial just to keep things clear. But once you do a quick Google, you'll find out, if you're using on axis and someone's confused, once they Google it, it'll be clear, as I, learned on that call, sink or swim. So yeah, when in doubt, use coaxial.
Yeah, so to summarize, coaxial is, the light itself. On axis is, I guess in a way it's like geometry, right? When we say geometry in a machine vision system, it's like, like where is the light being placed relative to the sample in the camera? And in this case, on axis means it's, on the same thing. Now I can only use
In
machine
line. Yeah.
vision hands to describe it. Yes,
Yeah.
in line.
Yeah.
Now I'm using machine vision hands. Yeah.
Yeah. But yeah, perfect summary. That's exactly it.
Yeah. And so to continue with, talking about coaxial lights, there are two terms, beam splitters and half mirrors that are, when they're used, they're describing the window glass panel that is installed inside a coaxial light, and that's what's helping, direct the light straight down to the sample and back straight up to the camera. I definitely think I heard half mirror before I heard of the word beam splitter. And that came like probably a year or two later into being a CCS. So is there a real difference between these two, or, do they also mean the same thing?
There is a real difference. So I'll kind of talk in terms of like CCS lights and less on like physics, but the typical coaxial light we have is made with a half mirror. And so it's essentially just a mirror placed at an angle. The light comes in. So this half mirror is kind of like a two-way mirror where you can like see through it. So the first reflection on that the light hits reflects the light down. The light reflects off the sample, passes up. Some of it gets reflected again, but a lot of it passes through to the camera, and then that's how the camera can kind of see through this mirror and how you get the like collimated light because it's being, directly reflected down by the mirror and then reflected back up. So that is how most of the CCS lights are used. A beam splitter is actually not like a thin half mirror, but it's like if you were to take a cube and cut it in half. So it's like half of a triangle. Well, it's like a triangle, like a right triangle, but like a cube. God, what is that term? Like sphere, but whatever. Or not like a
You're the
cylinder.
math expert here. I double majored in international relations and East Asian studies. They didn't
I'm
cover
gonna
this in talking about the history of politics in Central Asia.
I'm shocked.
Who would have
That's
thought,
hilarious.
right?
Who would have thought? But yeah, so it's essentially like, not instead of being a half mirror, because okay, so the problem with half mirrors is you can kind of have two reflection points. So you'll have, I'm gonna hold up a cell phone. So like if this is my half mirror, my first bout of light is gonna hit this reflection and reflect down, go up through the camera. But there's also this side of the half mirror that can be an issue too, and it in really small field of view, but really high resolution cameras. So like a, you know, 15, 20 megapixel camera looking at a couple inches is what we're talking about. You get what's kind of called ghosting, where you get the light reflecting off of this surface and reflecting off of this surface. And it can kind of make it seem like the object isn't quite in focus, but it is. It's just the coaxial half mirror light is causing a few issues. So there's two ways that you can kind of solve this. You can get a thinner half mirror, which is what our LFV3-G series does. Because it's thinner, the ghosting isn't quite as dramatic. Technically, there is still two reflective surfaces, but because they're closer together, it doesn't cause really a problem anymore. Or you can use the LFV3, is it -CP? I think so. It's really small, but it puts a beam splitter because the beam splitter, because it's shaped like a cube that's cut in half, there's only one surface to reflect off and down. So it doesn't cause the ghosting because it's only got one surface that the light is passing through. So that's kind of the difference on when you would use them and when they're needed. If you're using it for just like a standard, like we talked about before, reading a barcode on a sample that's been etched in or looking for dents and something shiny, it doesn't really matter. You can use the LFV3 and you'll be plenty. It's the really, high precise, really high resolution images that it can maybe cause a problem, and then you can just step up to the other two options. So you don't have to have a beam splitter and you'll still get good results.
Yeah, so the light is passing through a half mirror differently than it does through a beam splitter. And as a
Yeah.
result, you're getting clear images.
Yeah, so it's the light is doing the same of shining onto like an angled part. The difference is with the half mirror, you kind of get that double reflection, and in beam splitter, you don't. So that's what the difference is. Physics wise, that's the difference.
All right. Is it because the material is different? That's like why it's able to um uh create the higher resolution image, or is it I've always thought they were like both just glass and that somehow the beam splitter was fancier glass that that allowed it to have better resolution images. And is that just, my non-lighting expert stupidity? And
It's
there's more
probably
to it than that.
and so I think they're both like one. I don't think it's a better glass than the other. It's just the difference of like one being a thin line of glass and the other one being a whole half cube of glass. So like the beam splitter, like this is the half mirror. It's like this thin little piece, but like a beam splitter would be like if you take a Kleenex box and cut it in half. Let's see, like and cut it like in half like this. You only have like one edge. We're good. You only have one edge showing, and the rest of it is glass. So it would be like this is all glass. Um, so you just have more glass with the beam splitter. Long story short.
In my non-expert mind, for some reason, I think that would mean it's a worse image, but that's why you're the expert and not me.
It's the ghosting that'll get you, Emily. The ghosting.
Yeah. Yeah, that is in case anybody ever wanted to know, which I doubt they did, but the LFE3-G, the G stands for ghosting, and that it helps reduce ghosting with the slimmer half mirror. I remember like being in the room during that conversation. I just like naming products does not seem like a fun thing to do. You'd think it would be, but it isn't because you
You know,
debate like the most like small details.
I'm not gonna lie to you. I actually did not know that. I had no idea that's why it was LFE3G. I thought that they
Yeah.
just made it up for funsies, but that makes a lot of sense.
Like Apple comes up with the, I don't know, whatever Max or the whatever G or C or whatever on
Oh
their
yeah.
on their phones.
Yeah.
What do they mean? Whatever. All right. So, another optical tool that probably gets mixed up a lot is light control film and prism sheets. And I know that we sell light control film specifically. That is an accessory that CCS offers for its products. I sometimes wondered and never bothered to ask if they were just like a prison sheet and we were just too lazy to name it something else. Because we called one light control film and might as well just, call other future accessories that we come up with the same thing rather than come up with some new acronym to describe it, or are they two different things? Lindsay, explain,
They
enlighten me.
they are two different things. So as much as we love to be lazy in this situation, we are not being lazy. So a prism sheet is essentially, okay, we'll start over. Light control film, if you look at it, there's like a horizontal and a vertical. So what a light control film like horizontal does is it blocks when you have light that reflects off a surface, it reflects off scattered. If you especially if you have diffuse light, it's going to come out in every single direction. And so the parallel lights are the ones that come up straight, up and down. What a light control film does, the horizontal one will block the light and it will say I'm only letting the light that's coming off in the horizontal direction through. And then if you put the vertical one on top, which is perpendicular to the horizontal, it's going to say I'm only blocking the vertical light now. But we're already blocking the horizontal, so now we're blocking the vertical. So now the only light it's shining through is going straight, plus or minus a couple degrees, just because it's not perfect. It's just a film that's kind of blocking light. Versus a prism sheet is essentially like combining those two into just one sheet. So instead of having, one vertical and one horizontal, it's putting like tiny little pyramids kind of all over it. So the light just gets redirected straight up. So it's if you put a prism sheet and two, perpendicular light control films on, you're going to get pretty much the same image because you're doing the same thing. But one is just one sheet that you put down, so you have like simplicity in that regard. The other one, you get flexibility because sometimes like every once in a while, my image looks better with just horizontal light control film or just vertical light control film. So you kind of get the ability to test if you want, all of it, half of it, or none of it to make your image better. Our TH2 PM series, those are backlights with the prism sheet on them. And then if you don't buy the TH2 PM, you can buy the TH2 and then get light control film and put it on top. So your TH2 PM and your TH2 with light control film will have a very similar image. That's the difference between them.
Is that the main consideration when you're deciding, oh, am I going to, for example, get the TH2 PM versus a TH2 with light control film, that like what you said of do you want the flexibility to, take or have one or both when you would choose one over the other?
Yeah, I would say for a lab, I liked having light control film because I could, like I said, test out if just horizontal was better or just vertical was better. If you're doing testing and you decide that a horizontal and a vertical gives you the best image, then you could purchase the TH2 PM. In theory, I think that they both block about the same amount of light because it's just the light rays that they're letting through. They're letting the vertical light rays through, and that's going to be, the same on the TH2, how many vertical light rays it outputs. So I don't think the intensity should be much different. Maybe a little bit more intensity with the prism sheet than the light control film. But with backlights, a lot of times it's not really the problem because you're shining the light directly on, like at the camera. So usually we don't have a problem with intensity when it comes to backlighting. So that's not really something that you have to
Sure.
like consider too hard.
Then, now that we have demystified that, we can move on to the final set of terms, which is strobe time, pulse width, and exposure time. I feel like the confusion for me is that it comes up a lot when you're talking about lighting control, which is already kind of confusing, and then you throw these in and they kind of get all mixed up.
Yeah, overhead exposure time is the camera setting. It's how long the camera is taking the picture for. Strobe time and pulse width are the light settings. They essentially mean how long the light is on for. Um, the difference between strobe time and pulse width, those two can be pretty interchangeable, and no one's going to be confused if you say my pulse width of my light is 100 microseconds and my strobe time is 100 microseconds. The point will be taken. So those aren't ones that you necessarily have to worry about what you're using. But if you say my exposure time of my light is 100 microseconds, people would get confused in that regard. So pretty much, yeah, one's a camera setting, the other two are light settings. Good practice of the two is make sure your strobe time / pulse width is less than your exposure time so you don't have any jittering, messing up your image or anything like that. Or if your light's continuously on, then you have to worry about that. But then you don't have strobe time, so it doesn't matter.
The pulse width doesn't necessarily tell you, like, just because you say it's 100 microseconds, that doesn't tell you, like, how intense the light will be or how much it will be overdriven, right?
Correct. That's just telling you how long the light is on, and then there's another setting that would set the intensity of the light. So if you're not overdriving, it's usually 0 out of 255. And then so it could be at like 200 out of 255 is my intensity setting for my pulse width of 150 microseconds or milliseconds is more
They're
accurate.
all just different measures of time, basically, units of measuring time.
Yes, and what you're measuring. Like one, you're measuring the camera, the time the camera's on versus the time the light is on. But it's just time. So making the mistakes of confusing them isn't going to be that different because, my light is on for X amount of time. If you say the exposure time of my light is on for this much, really, we just know how long the light is on for. But it's better to know what we're talking about as we talk about it. So
We have covered all of our lighting terms for today, getting into exciting stuff that we have coming next month on Let's Talk Lighting. We are going to talk about Automate, which is, our biggest trade show of the year. Hooray! Coming up on June 22nd through 25th in Chicago. We'll be in the South Building in booth 3409, and we thought we might as well give everybody a sneak preview of all of the stuff that we're going to be having on display. So, getting really hyped up now. I can't believe it's only like 10-ish weeks away, right? At this point, as we're in early April now.
oh no,
I just really upset you, didn't I, by
you did.
bringing that up, by
You
bringing
did.
that countdown clock
Now I
right in
have
your
to
face.
go. I have to go check the status of our demos.
Yeah, leave it to me to put the pressure on you to stress you out. So yeah, look forward to that in mid-May. Other stuff, our general catalog is now out. You can look at it on CCS GRP, which is our parent company's website, but CCS America also has its print copy. So if that is, your preferred method of looking through it, you can just contact me or somebody else at the office and we can get you a copy sent. We'll also have those at Automate. So if you want to just, pop by our booth and pick up a copy, that might be one reason that you stop by. Don't come for the giveaways, come for the catalog. So much more fun than toys or other stuff.
Mhm.
Maybe we'll preview the stuff that we're going to be giving away in our
Ooh,
May episode
I
as
like that
well.
idea.
Maybe we'll workshop it. There's still a lot
Yeah.
of stuff to figure out for that episode.
Yeah.
Yeah, last thing, there's still time to register for our technical roundtable happening on April 30th in Rochester, New York. Lindsey will be there if you want to meet her and chat with her in the flesh. I will also be there as emotional support. That is my main job there, I think, aside from, videotaping and setting things up. So yeah, registration ends April 24th. So if you've been meaning to and you haven't, you forgot that was on your to-do list, maybe get it done now before you forget again. See, have I missed anything that we want to give people a heads up about?
No, those are the two big ones. What we spend all our time doing.
Events, email, LinkedIn, video, all the things, all of the
Yeah.
marketing things.
Mine right now is
Yeah.
the presentation for Automate. I'm a presenter at Automate. Maybe that's one thing. I get to
Yeah.
present. That'll be
Yes,
fun.
Lindsey will be presenting at Automate as an expert speaker, and you're doing it on high-speed applications, right?
Hmm. What happens when you go over 1,000 frames per second? I am so thrilled. I actually am. It should be fun, but there's always the like nervousness of presenting to a crowd where you don't like get to film it ahead of
Yeah,
time if you make mistakes.
yeah, a
You know.
live audience. But yeah, high-speed applications and all the stuff that goes into that. So if you have the access to attend all of those speaking sessions, make sure you go to Lindsay's because hers is the best, most superior of all. I don't know what other presentations there are, but in my total objective opinion, Lindsay's will be the best, 100% guarantee.
I'll take it. I'll take that. Thank you.
Yeah, perfect. All right. If you learned something new about machine vision lighting today, please give this video a like and subscribe to our channel. And you can follow CCS America and Lindsey and myself on LinkedIn. You can also send us your questions or topic ideas for this series. If there's anything you want to learn more about, we'd love to hear it so that we can, build this for our audience and, ultimately help them do machine vision lighting more effectively. So thanks again for listening, and we'll see you next time.